Hello everyone. In this video, we will discuss about the waveguide dispersion. In last video, we have discussed about the material dispersion and both will results in the intramodal dispersion. So before going to waveguide dispersion in detail, you must have basic knowledge of V number. We have already discussed this V number in first chapter. So basically, V number is a normalized frequency and very important for optical fiber communication. It determines the number of modes that can be traveled, that can be propagated in a particular optical fiber, or we can say it determines the number of mode in a fiber. So if we go to some data, key data set, then if V number is belongs to this in between these, then the fiber operate in single mode, and if belongs to this category, then it operate on in the multi-mode. So why we have discussed the V number? Because the waveguide dispersion is somewhat related with the V number. Actually, it depends on the V number. In case of material dispersion, the reason is refractive index. Variation in refractive index is the main cause of the material dispersion. But for the waveguide dispersion, it is dependent on the V number. So, what is the waveguide dispersion? So, basically, waveguide dispersion is due to dependency of group velocity on the fundamental mode as well as other modes on the V number. So, why we have discussed V number? Because this waveguide dispersion dependent on the V number, that is, and on the fundamental mode of optical signal that is traveling inside the optical fiber. So in order to calculate waveguide dispersion, we have to make some assumption. The first assumption is that the signal is not dependent on the refractive index. Or we assume that when we are calculating this waveguide dispersion, we assume that there is a no material dispersion. It means refractive index, there is no refractive index variation as a with reference to wavelength. So this is the assumption. So now the dispersion is dependent on only V number. So how to define, how will calculate the normalized propagation constant B? So it is calculated by beta square as a ratio of beta square k square minus n2 square. Here n2 is the refractive index, beta is a propagation constant, and k is again constant depending on the wavelength. Its value is given by k is equal to 2 pi by lambda. So this is the value of k. So normalized propagation constant B is calculated by this, and when we approximate this, then we will get value B. This we will get this value here. N1 and N2 is the refractive index. So again, when we solve this, we will get the value of propagation constant as a function of refractive index 2. And if we again approximate this using V number, then this will be the formula. And based on these formulae, based on this and this formula, numerical questions may be asked. So we have seen how the V number affects the dispersion, waveguide dispersion. So in the next lecture, we will see about the other modes of dispersion.